In the beginning, there was light. It filled the newborn universe like a flood, illuminating a cosmos that had just emerged from chaos. That light still echoes today, stretched thin by the passage of time, whispering through the darkness as the cosmic microwave background. Everything we see, every star, every galaxy, every planet, was born from that light. But like all things in the universe, even light has a lifespan. The story of the cosmos is the story of energy spreading, cooling, and fading. It is a journey from fire to frost, from brightness to silence. There will come a night when even light itself will die, and the universe will grow cold and still. But before that final darkness, there is a long and magnificent history of creation, brilliance, and decay. We live in what cosmologists call the stelliferous era, the age of stars. For billions of years, nuclear furnaces have burned across the universe, turning hydrogen into helium, forging heavier elements, and lighting up the void. The night sky we see is the glow of this era, a temporary blaze in the long timeline of existence. But like all ages, this one will end. The same physical laws that make stars shine also guarantee that their fuel will one day run out. The energy that now fills space is slowly spreading thinner, obeying the second law of thermodynamics, entropy, the measure of disorder that always increases. It is entropy that defines time itself, pushing the universe from structure toward chaos, from light toward darkness. The countdown has already begun. In the next few billion years, our own star, the Sun, will run out of hydrogen fuel. It will expand into a red giant, swallowing Mercury and Venus, perhaps even brushing against Earth. Its outer layers will drift away into space, leaving behind a small, dense core, a white dwarf, no larger than Earth but containing most of the Sun's mass. It will glow faintly for billions of years before fading into darkness. The same fate awaits nearly every star in the universe. On larger scales, galaxies like the Milky Way are also changing. Over time, gravity pulls galaxies together while the mysterious force of dark energy drives them apart. About 4 billion years from now, the Milky Way will collide with the Andromeda Galaxy. The two will merge into a new elliptical galaxy, their stars rearranged in vast new orbits. From a distance, it will shine even brighter for a while, but that brilliance will not last. Star formation will slow as the available gas is used up. In the long future, galaxies will stop making new stars entirely. As the universe continues to expand, its galaxies will drift farther apart. Because of dark energy, that expansion is accelerating. In 100 billion years, most galaxies will have receded beyond the observable horizon. Their light will never reach us again. To future observers, the universe will appear nearly empty. The cosmic web of galaxies that defines our universe today will vanish from view, replaced by an eternal black sky dotted with only the faint remnants of local stars. The age of light will fade gradually. The last bright stars, the massive blue giants that live fast and die young, will burn out first. The smaller, cooler red dwarfs will endure for trillions of years, quietly fusing hydrogen into helium at a slow, steady pace. These stars are dim by our standards, but they are efficient, conserving their fuel and living far longer than the universe has existed so far. Even so, their time will come. Eventually, the last red dwarfs will exhaust their hydrogen, their fusion will stop, and they will cool into black dwarfs, cold, dark remnants that no longer shine. When that time arrives, the universe will enter a new age, one without light, where energy is scarce and matter is scattered thin. But for now, we are still in the Golden Age, the brief moment in cosmic history when stars light up the darkness. Our existence depends on this narrow window. The elements in our bodies were forged in the hearts of dying stars. The warmth of the sun powers the chemical reactions that sustain life. Even the air we breathe is the product of starlight, filtered through the chain of creation that began billions of years ago. We are made of the same fire that will one day fade. As stars die, they leave behind strange remnants, white dwarfs, neutron stars, and black holes. These objects are the universe's memory, the relics of its most brilliant moments. A white dwarf is the faint afterglow of a sun that has burned out. A neutron star is the collapsed core of a massive star, its atoms crushed so tightly that protons and electrons merge into neutrons. And a black hole is what remains when gravity wins completely, pulling everything into a point from which not even light can escape. Over time, these remnants will dominate the universe. The glow of active stars will fade, and the light of galaxies will dim. Black holes will drift silently through space, devouring what little matter remains. Collisions between black holes will send ripples through spacetime, gravitational waves echoing through an ever-quieting cosmos. Eventually, even those waves will fade. The era we live in is fleeting, a bright spark in the timeline of the universe. From the moment of the Big Bang until now, the cosmos has been expanding and cooling, evolving from simplicity into complexity. Stars formed, galaxies clustered, life arose, all fueled by the leftover energy of creation. But entropy ensures that this energy will not last forever. Each burst of light, each act of creation, leaves behind a trail of disorder. Over trillions of years, energy will spread evenly throughout space until no more work can be done. That is the essence of the universe's story. A transformation from concentrated energy to equilibrium, from brilliance to stillness. To imagine the end is to imagine time stretched to its limits. The universe has existed for 13.8 billion years. The sun will die in 5 billion. The last stars will fade in about 100 trillion. Beyond that, time becomes almost meaningless. Trillions of years will pass, and the universe will continue to expand. Galaxies will vanish beyond the cosmic horizon, their light forever unreachable. What remains will be a scattering of cooling stars, drifting through darkness that grows ever colder and more silent. Yet even in that distant future, there will still be light. White dwarfs will glow dimly, slowly radiating their remaining heat. Neutron stars will emit faint pulses as their magnetic fields fade. Black holes will bend and distort the faint radiation around them. The universe will not end suddenly. It will fade like the last embers of a dying fire, each spark growing weaker until none remain. It is difficult to grasp such immense timescales where years stretch into trillions and beyond. But in that slow decline lies something profound. The universe is not dying in despair, it is simply following its nature. Entropy is not destruction, but transformation. The spreading of energy, the smoothing of differences, the return to balance. Every act of creation is balanced by decay, every birth by death, every light by shadow. As we look at the stars, we are witnessing a universe still full of energy and movement, still young compared to what it will one day become. The galaxies glowing in the night sky are not eternal. They are temporary flames in a vast, dark sea. And yet, in their impermanence lies their beauty. To exist at this moment in cosmic history is to see the universe at its most alive, its most luminous. We live in the brief twilight between creation and eternity, in the age of light before the long night to come. The story of the universe is not a tragedy, it is a masterpiece of balance. It began with light and will end with darkness, but both are part of the same cosmic rhythm. From the first spark to the final shadow, everything that exists follows this flow. We are witnesses to its middle act, the era when stars still shine, when galaxies still collide, and when life still thinks, feels, and wonders. But the light is fading. It will not vanish all at once, but slip away, star by star, galaxy by galaxy, over unimaginable stretches of time. The glow that now fills the universe will dim until the last star flickers and dies. The cosmos will not end in fire, but in silence. Yet even in that silence, the memory of light will remain, carried in the cold and the void, the trace of everything that ever was, slowly fading into forever. The universe is vast, but its brilliance is temporary. Every star that burns is living on borrowed time. Every galaxy, no matter how magnificent, will one day grow dark. We exist in the middle of that great unfolding, in a fleeting era when stars still shine and galaxies still sparkle. But if we stretch our imagination far beyond human lifetimes, into the deep future, the universe transforms into something unfamiliar. It becomes quieter, lonelier, and colder. The great age of light begins to fade, giving way to an age of remnants. Over the next few trillion years, the stars that fill the night sky will die one by one. The massive blue stars, those that shine brightest, will disappear first. Their fuel burns quickly, and their lives end in spectacular supernovae that leave behind either neutron stars or black holes. Smaller stars like our Sun last longer, but even they will eventually exhaust their hydrogen fuel. The last to die will be the red dwarfs, tiny, dim suns that can burn for trillions of years. When they finally go out, the universe will lose its last steady sources of light. As each star reaches the end of its life, it leaves behind a relic. White dwarfs, dense, cooling embers of former suns, will continue to glow faintly for billions of years before fading completely. Neutron stars, the crushed cores of massive suns, will spin more and more slowly as their magnetic fields decay, their light pulses growing fainter with every passing age. Black holes, the most extreme remnants, will continue to consume matter and energy for as long as anything remains near them. But as the galaxies age and the stars vanish, even black holes will find less and less to feed on. The universe, once filled with the light of countless suns, will grow dim. By the time the last red dwarf flickers out, around 100 trillion years from now, the stellar era will be over. The universe will enter what physicists call the Degenerate Era, a time when no new stars are born and only the remnants of long-dead ones remain. The galaxies that now glow like islands of light will fade into ghostly shadows. The only illumination will come from the faint heat of white dwarfs and the occasional flash of collisions between dark remnants. Even in this darkness, strange things will still happen. Gravity never sleeps. The remnants of stars, white dwarfs, neutron stars, and black holes will continue to drift and interact. Some will collide, sending bursts of energy across the cold universe. Others will fall into black holes, feeding them for the last time before everything grows still. Over unimaginable spans of time, these gravitational interactions will slowly unbind galaxies. The stars and remnants will scatter into intergalactic space, leaving behind nothing but the faint gravitational ghosts of the past. Eventually, only a few faint points of heat will remain. The white dwarfs, now fully cooled, will become black dwarfs, cold, dark spheres of carbon and oxygen. They will no longer shine, but they will still exist, slowly radiating the last traces of their stored energy. Inside their dense cores, strange processes may still occur. Over quadrillions of years, quantum tunneling could trigger reactions that cause them to explode in faint, brief flashes, like dying memories of the age of light. If protons are truly stable, these remnants will endure indefinitely, frozen monuments to a bygone era. But if protons eventually decay, a possibility some theories predict, then even these atoms will not last forever. In that case, the matter that makes up all stars, planets, and people will slowly disintegrate, one proton at a time, over a period of 10 to the 40 years. That number is so vast, it defies comprehension. By then, the universe will be an ocean of subatomic dust, a place without structure or form. In the Degenerate Era, black holes will become the dominant objects in the universe. They will sit in isolation, surrounded by darkness, occasionally swallowing the stray remnants that drift to us. For a while, they will rule an otherwise empty cosmos. But even black holes are eternal. In the 1970s, Stephen Hawking discovered that black holes emit faint radiation, now known as Hawking radiation, caused by quantum effects namely the galaxies. This radiation carries a low energy, meaning that black holes slowly lose mass over time. The process is incredibly slow for large black holes, but given enough time, it becomes inevitable. Small black holes will evaporate first, releasing bursts of energy in their far remains. The largest, like those at the centers of galaxies, will take far longer. The supermassive black hole, the heart of the Milky Way, will take about 10 to the power of 500 years to completely evaporate. A timescale so long it dwarfs everything that came before it. By then, the universe will be unimaginably old. There will be no stars, no galaxies, and no light. The only activity left will be the quiet hiss of black holes fading away.
When the last black hole dies, the universe will enter its final phase, the dark age. The cosmos will be nearly empty, filled only with the faintest traces of radiation, drifting particles, and the echoes of forces that no longer have meaning. Space will continue to expand, and the average temperature of the universe will drop close to absolute zero. The cosmos will not end in fire, but in cold. It will not collapse, but fade. Time will still pass, but nothing will happen. The universe will reach what physicists call heat death, a state of maximum entropy. Energy is evenly distributed, and no more work can be done. It is the ultimate stillness, the end of all structure and change. No new stars will form, no new poles will move, and no light will shine. The cosmos will be filled with nothing but the quiet hum of background radiation. Stretched so thin, it will eventually vanish into silence. It's a haunting vision, but not one without beauty. The end of the universe is not an explosion, a slow, graceful unwinding. Everything that was once concentrated, stars, galaxies, will spread evenly across space. The same laws that gave rise to creation will bring about its dissolution. Entropy does not destroy, it balances. It transforms energy from one form to another, until more transformations are possible. The death of light will not come suddenly. It will happen slowly, imperceptibly, as stars fade and energy disperses. Even as the last black holes appear, faint whispers of radiation will continue to ripple through the cosmos, carrying the final traces of existence. Eventually, those too will fall, leaving behind dark, quiet rooms where time stretches endlessly, but nothing allows to mark its passage. This may sound like an end, but it was also the completion of a cycle that began with the Big Bang. The same expansion that birthed galaxies will eventually erase them. The same energy that gave us stars and life will spread so thin that it can no longer sustain even. The universe does not die. It transforms from a state of order and brightness to one of perfect equilibrium. It becomes a vast, eternal stillness. If consciousness still exists in some form during this distant future, perhaps in far-evolved species or artificial intelligence, it would witness a universe growing colder and quieter, its lights blinking out one by one. It might look out into the endless darkness and see only memories, the faint glow of long-dead galaxies, the dying shimmer of fading black holes. To such an observer, the cosmos would seem at peace. And perhaps that peace is the final purpose of everything that came before. The stars burn not to last forever, but to bring balance. Their deaths are not failures, but necessary steps in the grand evolution of energy and time. The universe, like all living things, grows, matures, and eventually rests. The light that fills space today is a brief phase in a story that spans eternity. Someday, even the word someday will lose its meaning. There will be no clocks, no observers, no boundaries, only space expanding into infinity, filled with nothing. But even then, the memory of the universe's light will remain written into the fabric of space-time itself, a silent record of the beauty that once was. The night sky we see now is not eternal. It is a moment, a fleeting glimmer in the long life of the cosmos. We are witnesses to its middle act, standing at the edge of light before the long descent into dark. But in that light, in every star and galaxy, in every photon that reaches us across the void, there is a story that began at the dawn of time and will end only when the last particle fades. The death of light is not just the end of the universe, it is the final whisper of everything that ever lived. The universe is patient. Its clock does not measure in years or millennia, but in eons that stretch beyond comprehension. In its infancy, it was a furnace of creation. Now it drifts towards stillness. The story that began with fire and light will end not with an explosion, but with silence. The final act of the cosmos unfolds slowly, gracefully, as time itself begins to lose meaning. What remains after the last star fades is not chaos, but a profound equilibrium, a universe where nothing changes because nothing can. After the last black holes evaporate, after the last proton decays, the universe enters its quietest and longest era, the Dark Era. It will be a place of endless night,
a sea of emptiness where the temperature hovers just above absolute zero. There will be no stars, no galaxies, no planets, no light. Only the faintest particles and low-energy photons will remain, spread evenly across infinite space. All the structures that once filled the universe will be gone, dissolved by the relentless march of entropy. In this final epoch, space itself continues to expand. The few remaining particles drift apart forever, each one alone in an infinite void. The distances between them grow so vast that they can no longer interact. Every remnant of matter, every faint bit of radiation, stretches with the fabric of space until it becomes undetectable. Time continues, but it has no events, no milestones, no observers. It is existence without experience, being without change. To understand this ending, we must return to the beginning. The universe started in a state of extraordinary order, dense, hot, and full of potential. From that order came everything we know: galaxies, stars, life. But the second law of thermodynamics dictates that order always decays into disorder, that energy spreads until it can no longer be used to create or sustain structure. Entropy is not a villain in this story. It is the law that makes time possible. Without it, nothing could evolve or exist. The same principle that created stars now brings them to an end. The universe's journey from light to darkness is not random. It is the unfolding of inevitability. As energy disperses, it becomes uniform, until every part of space has the same temperature, the same emptiness. Physicists call this the heat death of the universe, the state of maximum entropy. It is a universe at perfect equilibrium, where all processes have stopped because there are no longer any differences in energy to drive them. Everything that once existed will have decayed into a smooth, uniform nothingness. And yet, even in that stillness, the fabric of space-time remains. It is stretched thin, vast beyond imagining, but it endures. Quantum physics tells us that, even in the emptiest vacuum, there are fluctuations, tiny, random bursts of energy that appear and vanish in an instant. On human timescales, these quantum flickers are meaningless. But in a universe where time stretches endlessly, even the smallest possibilities can become significant. Over unimaginable spans of time, numbers so large they exceed 10 to the 100th or even 10 to the 100th power times 50 years. One of these fluctuations could, by chance, create a new burst of energy. A new bubble of space could form, expanding rapidly, filled with its own laws of physics and constants of nature. To the inhabitants of that new universe, it would appear as a big bang, a new beginning born out of the quantum silence of the old. If this is true, then the death of our universe is not an end, but a transformation, one cycle in an infinite chain of creation. This idea, known as eternal inflation, suggests that universes may be constantly being born and dying, like waves rising and falling on an endless sea. Each universe may have its own version of physics, its own stars, its own light. If that is so, then our universe is not unique. It is one thread in a cosmic tapestry far larger than anything we can imagine. And perhaps, when our universe reaches its final silence, another will already be singing its first note. But whether or not new universes are born, the fate of ours remains the same. The death of light is inevitable. The stars that once illuminated the void will vanish, the galaxies that once danced together will drift apart, and the black holes that once anchored the cosmos will fade into nothing. What will remain is a universe in perfect balance, infinite, cold, and quiet. It is strange to think that everything that ever lived, every moment of joy or tragedy, every burst of starlight and whisper of life will one day be gone. But perhaps the meaning of the universe is not found in how long it lasts, but in what it creates while it burns. For billions of years, it has created beauty, complexity, and life. It has turned chaos into pattern, darkness into light, simplicity into consciousness. Even if it all ends, those moments existed, and that may be enough. When the final photon fades and the last trace of energy disappears into equilibrium, there will be no one left to mourn the loss. But the universe itself will have achieved something profound. It will have completed its transformation from raw energy to infinite stillness. Every law of physics, every particle, every spark of life will have played its part in this grand evolution. In this silence, time no longer has meaning. Without change, there is no before or after. The universe simply exists, frozen in a state of infinite calm. If any consciousness could somehow endure to witness this, it would see not emptiness, but perfection, the ultimate symmetry where all motion and energy have ceased. The universe will have reached its final state, the only one where nothing more can happen. And yet, even then, the echo of everything that came before will linger in the structure of space-time. The curvature of the cosmos, the faint quantum hum of the vacuum, the ghostly imprint of galaxies long gone, all of it will remain as the quiet memory of creation. The universe will have forgotten its stars, but it will remember their warmth in the faintest possible way, as a background that will never fully vanish. This is not a story of despair, but of completion. The universe will end not in violence, but in peace. It began with a burst of unimaginable energy and will end in balance. It started with light and will finish with silence. The arc from creation to stillness is the most natural story imaginable, the story that all things, even universes, must follow. For us, living now, this far future is beyond imagination, but knowing it exists adds depth to our own moment in time. The stars that shine tonight are part of a temporary age, one that will never come again. We are among the lucky few who live during the universe's golden age, when galaxies still glow, when light still fills the dark. To look up at the night sky is to see the cosmos at its most alive. When you see a star, you are seeing entropy reversed, order fighting back against the inevitable. Every point of light in the sky is a victory, however brief, over darkness. The stars burn because the universe allows it, for now. They burn because gravity and time, for this short cosmic heartbeat, create conditions for life and light to exist. And when their time ends, they will return their energy to the vast sea from which they came, adding their warmth to the story of everything. The death of light is not the end of meaning. It is the universe's way of completing its sentence. From the first moment of the Big Bang to the last flicker of radiation, everything that happens is part of the same breath, an exhalation that spans eternity. And even when that breath ends, the silence that follows will still carry its memory. There will come a night when even light dies. But that night is not tragedy. It is fulfillment. It is the quiet after the song, the stillness after the storm. The universe will rest, its story told in full. And if another cosmos is ever born from its remains, it will carry within it the faint echo of ours, the memory of a universe that once burned with light, dreamed with life, and then, at last, found peace in the endless dark